teachers often struggle with the idea that, when we're teaching something, didn't we cover this like 2 weeks ago, and how come students don't remember it? And part of the reason why they don't remember is because they're just memorizing it. We're not pushing them deeper. We're not helping them develop a conceptual understanding with the problems that we're asking them to do. And if the problems only ask them to memorize the formula and use it, then that's all anybody's ever going to do. Focusing on that level of understanding is not enough. And this is more connected to the Common Core, and even larger than the Common Core, how people learn, ideas about how people learn, it's a focus on depth over breadth. Students need to develop a deeper conceptual understanding. And that all starts with the kind of problems that we ask our students to do. I'd like you right now to please focus on the problem on the left. The problem on the left. At the Institute, we looked at a procedural problem and then the more non-routine conceptual problem next to it. We looked at a procedural problem, procedural area problem. And the problem was, a woman has a room that's 10 feet by 15 feet and she wants to put out a carpet. How many square feet of carpeting is she going to need? So how did you get 150 square feet? Anthony, how did you get 150 square feet? 15 times 15. And everyone said it's an area problem. I said, how did you know it's an area problem? Oh, because it looks like every area problem I've ever done. And there's no discussion, there's no depth. Does anyone understand what that means? Or is it just a multiplication problem of 10 times 15 with this, real life situation kind of chunked around it? This one here, Martha's carpet, if students can do this, if you can do this, 150, what have you learned? Nothing. There's nothing you learn from this. You just do it. You know how to do it, and you do it. The second problem is it's called the garden problem, and it is about a woman named Sarah who's got 24 feet of fencing, and the question asks you to design the dimensions of a rectangular garden that has the largest amount of area.
4 by 8, and your area is getting larger each time, so 5 by 7, we've got 35, and finally 6 by 6 is 36.
The answer is the 6 by 6, the square. But there's lots of different ways to get there. You can draw pictures, you can make a chart, you can do it algebraically, manipulating the formula. So that's an example of one where there's one answer, but there's lots of different ways to do it.
Sarah's garden, you had to dig deeper into that knowledge, and it was a lot more work. We had to analyze it and apply the knowledge to a different situation.
The other problem that we did during the Institute was looking at mean, median, mode. The conditions of the problem were you have to come up with a set of numbers, that's 10 numbers, that has a mean of 7, a mode of 3, and a median of 6. How else did people get started? Yeah?
I made myself like a number line with 10 blank spaces.
Okay, good. What do other people do to start? Yeah,
kind of worked backwards. I know that if the mean has to be 7, then 10 numbers have to add up to 70. Yeah.
So not only are there different ways to answer that, but there are infinite correct answers to that.
So, but it could be any combination that equals up to 70.
11.
How many combinations are there?
Oh gosh.
That's another whole other problem.
There's tons, lots.
Choosing the right problem. The right problem should have different methods that can be used to solve it, and sometimes even different answers. So we're looking at two because I think it's really important for teachers to see the procedural problem and then the more non-routine problem, and to see, oh, how can I make the problems more like the non-routine problems? For activity 2, for the pre-training assignment, I had you guys read a bunch of things from math. The second was an article that talked about ways to take traditional textbook workbook problems and convert them into open-ended problems. So what they did was they chose traditional problems from a variety of sources, but then they made them more open-ended. And so I'm going to give them that document, and in pairs or small groups have them use the DOK sheet that has the 4 levels and the descriptors, and just have conversations. I want them to have to use that sheet, and so I'm hoping that in the conversations that they have, they'll get a deeper understanding.
First we found out the perimeter, there are multiple ways to find out the perimeter, just like there's multiple ways to design this container. But then you have to find out the maximum area in the garden problem, and here we're looking for the maximum value. So I think that there are multiple ways to get to the solution, but
whatever you want to do.
Many adult education teachers rely on the workbook. So I want to address that. I want to say don't use it, but I want to say here's a way to do it. Here's a way to use it that pushes it and makes it more effective for the long term, what our goals are. Yeah, I live 40 miles from the airport. The speed limit is 20 miles per hour. What time should I leave? Talk to me a little bit. When do I need to leave? 4? Why 4? In life, when you have to do math, the conditions are not neatly prescribed for you. You have to make choices as to what those conditions are, and I think that is something that we need to bring into our mathematics instruction a lot more. Mathematically, you can figure that out, right? Except, now tell me what are all the other things I would need to think about?
Yes. You gotta carry your bag.
I might need to stop for gas. I'd have to think about that. I want to carry your bag. What are other things I would need to think about?
Rush hour.
Traffic. There should be ways for different students to approach and attack the same problem. And I think that quality actually addresses a challenge that all of us in adult literacy face. Students come in with different pockets of knowledge, and in one class you'll often have a pretty wide range. And so focusing on these non-routine problems, choosing the right problem, can actually turn that into a strength.